Topic 3.7 is about solutions and mixtures. So the objective for this topic is to calculate the number of solute particles, volume, or molarity of solutions. So really quick, let's go over what a solution is. A solution is a homogeneous mixture of two or more substances in the same phases, so solids, liquids, or gases. The solvent is the substance with the greater quantity. The solute is the substance or substances with the smaller quantity. So what there's a lot of is the solute, what there's a little of, I said that backwards. What the solvent is what there's a lot of. What the solute is what there's just a little of. And then we use concentration as a way to express the solution composition. And the concentration that we're specifically going to look at is molarity. So molarity is symbolized by a capital M. When you talk about the concentration of something, you can say that it's 1.5 molar. And the units, so the units are molarity, capital M. To calculate it, you do moles of solute divided by liters of solution. So you have to make sure that your solute is in moles. Oftentimes it's in grams because that's what we measure in lab. So you'll have to make sure that you convert to moles. And then your solution is in liters. So the big part here is to make sure that if it's a small volume given in milliliters, that you convert to liters. We can use molarity as a conversion. If you know the moles and you know the concentration, you can find the volume. Similarly, if you know the volume and you know the concentration, you can find the number of moles. So this is really useful when you're doing stoichiometry and you're given the solution concentration of a reactant instead of the mass. So if you're working with a reaction and one of your reactants is in solution, so it's dissolved most likely in water, you're most likely going to measure out a volume of that and know the concentration. So you're first going to use your molarity as your conversion to get into moles, and then you can continue to do stoichiometry from there. There are some other concentrations that will not be tested in this class. However, I want you to be aware of them because they might come up in another class or even just in regular everyday life. The first is molality, which is very similar to molarity, but it's the moles of solute divided by kilograms of solvent. Molality is used when calculating boiling point elevation and freezing point depression for colligative properties. You'll also see sometimes mole fraction. So that's literally the fraction of the moles of the substance you're looking at compared to the total number of moles in the solution or mixture. Mole fraction is something that's sometimes used with some older AP questions. So you might run across that if your question source is on the older side. And then the last one is weight percent. And a version of this is also percent by volume. And so that is just like any other percent. So if it's weight percent, it's the mass of one component divided by the total mass times 100. If it's percent by volume, it's the volume of one component divided by the total volume times 100. So this is something that you will sometimes see in, you might see it in drug composition, or you might see it in food composition as well. So there are other ways besides molarity that we can calculate concentration. In this class, we are going to focus solely on